Hello class! In the last video lecture, napag-usapan natin kung paano mag-solve ng energy balance for anaerobic process. So, hindi siya aerobic. Okay? Now, this time, ang isusunod natin ay energy balance example for aerobic process naman. Ibig sabihin, you will charge the fermenter with air or oxygen. And this example that we have here is citric acid production by Aspergillus niger. So we have the fermenter and it operates at 30 degrees Celsius. Now in a period of 2 days, okay, nakapag-produce yung fermenter natin ng 1.5 kg of citric acid and kasama na dyan yung 500 kg of biomass and 100 kg of water vapor. Okay? Gaano kadami yung oxygen na nilagay? 800 kg siya. At meron pa siyang kasamang ammonia, being the nitrogen source. And how much glucose was charged into the fermenter? So, 2,500 kilograms of glucose. Now, aside from that, mayroong power input to the system. And probably, this is by some mechanical agitation. Kasi, you have the fermenter, alam naman natin na yung organism doon, kailangan naka-broth siya. So, you have to mix, okay? Or agitate the broth. Pangalawa, syempre, kailangan mong gawin yun kasi meron kang charge na oxygen dun sa system. So, the oxygen, being that the organism is aerobic, so kailangan well-dispersed siya dun sa broth. So, malamang meron tayong i-account na mechanical agitation. And it's found that the power input to the system by mechanical agitation is 15 kilowatts. Okay? Now, the question here is, again, we have to estimate the cooling requirement of the system. In other words, kailangan natin malaman kung gaano kadaming heat ang na-evolve from the system para malaman natin kung ilan yung electricity or energy requirement natin. Alright, so what will be the general reaction or ano yung itsura ng chemical or biochemical reaction na nangyayari dun sa fermenter? So, we take it as glucose, okay, being our carbon source, plus yung ating oxygen, plus ammonia, forming this time, again, yung biomass, no? Tapos, meron kang carbon dioxide. Okay? So, carbon dioxide, water, and citric acid. Now, nakita nyo sa diagram or sa flowchart natin, wala yung carbon dioxide. Okay? Don't worry, ma-address natin yan later on. Now, what is our general energy balance equation for a bioprocess? If you review the video lecture last time, so 'di ba, ang nakuha natin is minus the enthalpy of reaction minus yung we have to account for the evaporation minus Q plus shaft work equals 0 kasi steady state yung assumption natin again this time. Now, each term here in this equation refers to the 2-day culture period. Okay? 2 days kasi yung duration ng ating culture or ng fermentation. So, we have to keep that in mind. Now, how do we calculate this? How do we approach this problem? Remember, this is aerobic, hindi siya anaerobic. So, may pinagkaiba ba kung aerobic o anaerobic? Yes, actually. You will find that energy balances involving aerobic processes is more straightforward compared to anaerobic. Kasi natatandaan nyo dun sa previous discussion natin, if your process is aerobic, according to Rowell's and co-workers, let me write that down. Rowell's and co-workers, naalala nyo yung value, you can actually determine already yung enthalpy of reaction kasi according to them, diba remember, nagplot sila yung degree of reduction versus yung enthalpy of combustion divided by the number of carbon atoms, and they found out that the line, when you do that, is a pretty straight line, and the slope is equivalent to Q. Okay? And that Q, or heat, is the slope of the line, and that refers to the enthalpy of reaction. Okay? So, this value of the slope is constant. Nakita nyo sa pagka-straight line ng graph. And according to Rowells and company, they take that slope, or the value of Q, is minus 115 kilojoules, okay, per mole of electrons. All right, electrons transferred to oxygen. Now remember, in aerobic processes, the final electron acceptor will be oxygen. Kasi 'di ba, you have a substrate like glucose or lactose, so it undergoes glycolysis and then it goes to the Krebs cycle. And the products of the Krebs cycle, which are NADPH and FADH2, will go to the electron transport chain. So it's a chain of electron transfers, and sa dulo ng electron transport chain, nandun nakatunga, nag-aabang si oxygen para matransferan siya ng electrons. Okay? And how many electrons ang kayang tanggapin ni oxygen? So oxygen is O2, right? And one atom of oxygen has an oxidation state of -2. So -2 times 2 electrons, or -2 times 2 atoms rather, that will be 4. So you will multiply this by 4. Alright? So therefore, ang ating enthalpy of reaction, ayan na yan. 115 times 4. So that's minus 460 kilojoule per mole. Okay? Now, this now, yung naka per mole siya, ibig sabihin per mole of the substrate consumed. So, ang substrate natin dito, okay, it's 8, sorry, so yung oxygen natin pala, so na-typo ako dito, but hindi siya 800 but rather 860 kilogram of oxygen. Okay? So, naka per mole na siya ng oxygen, and then you have to just multiply that by the amount of oxygen. So, ilan ba yung amount ni oxygen na meron tayo? Yun nga, it's 860 kilogram times 860 kilogram. Kaso nga lang, naka per mole yung ating enthalpy of reaction. So, kaya kailangan natin i-convert. So, how? So, convert muna natin yung gram to kilogram. So, 1 kilogram is 1,000 grams. And then, convert din natin yung mole to grams. So, 1 mole is 32 grams of oxygen. So, finally, ang ating heat or enthalpy of reaction is just minus 1.24 times 10 raised to 7 kilojoule. So again, reminder lang, no, na this value, okay, this minus 460 is constant. So you have to remember this value for aerobic processes. So that's already the enthalpy of reaction. Wala ka nang gagawing iba pang calculation. That's the amount, or that's the amount of energy we're looking for already. Iko-convert mo na lang siya using whatever amount of oxygen that you have and some other conversion factors. Okay, so this is now our enthalpy of reaction. Kaso nga lang, doon sa ating working equation above, we have to account for some evaporation kasi according to our flowchart here, mayroong kilogram water vapor amount, no? 100. So, kailangan nating isama yan. Let's collectively look for this part here. So, ilan yan? So, MV times the heat of vaporization, which is given, okay, 2430.7 kilojoule per kilogram. Pero ilan mo ng water ang nag-evaporate? So 100 kilogram yan. Tapos yun ngang enthalpy of vaporization na 2430.7 kilojoule per kilogram. Okay, so ang may iwan dyan is kilojoules. So you will get 2.43 times 10 raised to 5 kilojoules. Okay? Now, how about the power input? Okay, yung WS or work or shaft work. So, ang given is 15 kilowatts. Now, we have to be consistent kasi puro kilojoule yung ating unit dito sa enthalpy tsaka sa enthalpy due to evaporation. So, therefore, we have to convert this. Yung 15 kilowatts is basically 15 kilojoule per second, di ba? I-convert natin yan, how? I-multiply natin ng time. So, ilan yung time? Sabi sa problem, 2 days yung duration ng fermentation. Na yung 2 days na yan, convert natin yan sa seconds. Diba? Ang 1 hour is 3,600 seconds. And yung day to hour conversion is that 1 day, of course, 24 hours. And you will get here 2.59. Okay, let me double check. Yep, 2.59 times 10 raised to 6 kilojoules. Okay, now we have all the terms except for yung Q, of course. So kung imomod or if we're going to solve for Q using this equation, magiging Q equals, so that will become minus delta H minus the evaporation term, and then plus the shaft work. So ano yung delta H reaction na nakuha natin? So negative daw of negative 1.24 times 10 raised to 7 minus 2.43 times 10 raised to 5 plus the shaft work of 2.59 times 10 raised to 6. And you will get here a value of Q, which will be 1.47 times 10 raised to 7 kilojoules. Positive siya, ibig sabihin, it indicates that heat must be removed from the system. Okay, so that is our final answer. Now, I want you to practice this problem one more time, pero hindi mo ilalagay, so you will not take into account yung evaporation. So if there is no evaporation, if you will neglect the water vapor form, ano kaya yung mangyayari sa cooling requirement value natin?